again, everybody, and welcome to the next video in our series. Now that we've gotten our introductions out of the way and we're familiar with at least the requisite paperwork that has to be turned in for sake of network access, permissions, syllabus, and so forth, now we're going to get into a little bit of a math assessment. Now, for most of you, this is going to be old hat. This is the type of thing that you've learned some time back, but haven't necessarily had an opportunity to apply it a great deal. What we're going to do is we're going to go over a couple of slides, and all of these 4 individual PDF/Word files are all attached to your Google Classroom Week 1 in terms of you being able to pull them down and print them out as you see fit. I'm going to have printouts ready as well, but this is, again, a video that, in case you missed it in class, you're able to catch up on the intro to. So again, we're going to assess your ability, or really, ramp up your ability to apply math in so far as how it relates to design drafting. In other words, you're going to spend a lot of time, with equivalencies and being able to apply value to length, volume, scale in such a way where you can seamlessly go between fractions, the decimals, even equivalency in fractions, and of course whatever that amounts to in terms of percentage, because sometimes we quantify our designs that way. So for starters, I wanted to reference this 01D doc called Math Decimal Fraction Conversion References. This is strictly a reference chart. Now, you can get this type of information obviously most anywhere, but what's handy about this first page of the doc is how it relates fractions to equivalency, fractions to decimals to percentage. Now, again, this is the type of thing that is probably old hat for you, but at the same time, I can't stress it enough. We will eventually get into the metric systems as well, but when you're working within the metric system, that's typically base 10. That is base 10 applied math, and it's easier to comprehend. Fractions, the decimals, to equivalencies along these lines, you need to review this and you need to be comfortable with it, because a lot of your units of measure are going to vary between different denominations in terms of fractional values, and then you gotta have to break that down to decimal, because whether you input it as a fraction or a decimal, either on the board or in CAD systems, you need to know what that stacks up to in terms of your overall size and length. The second page to that same doc is just a broken down fraction to decimal chart that doesn't include anything other than in 64th increments all the way from 0 to 1. And these are the typical values. You're seldom going to go into anything any finer, certainly not in here, and even in industry. You're working in the inch system, you're seldom going to go into anything much finer than a 64th for most designs. And again, if you do, then you're getting into really microscopic type, maybe gauge design. But for our purposes, it helps to know the fraction decimal equivalency chart in this way. I want to switch now over to this rule chart, which is 01A. So we're kind of going out of alphanumerical order, but this is all under week 1, the math assessment portion. This is a reading a rule pretest. Again, this is going to be dependent on how often you actually apply what's relatively straightforward here in terms of the inch measurement system. But as you can see, just as an intro, there's capsules with an arrow pointing to a gradient or a mark that indicates some portion of an inch. If you've got marks that are beyond a whole number, you incorporate that whole number into your answer, but basically you count the number of increments between one whole number and the next, and you know that that's basically the denomination of how many increments you have between inch values. This is very basic, but I want to make sure that we grasp this, because this is an expectation going in that you are able to knock this out. That's about all I want to leave you with on that going in. But this, unlike the first handout, this is one that you'll actually want to go ahead and complete in class today, once we get through this review. The next slide over is going to be part one of a three-part assessment. So after you get through the reading the ruler one-pager, you're going to have a three-pager with 3 parts. And that starts with 01B file, the doc file. And again, I apologize for these going out of order, but just know that outside of that first document, everything else now is something that we're going to be completing. And as you can see, I included the fraction decimal chart on this part 1 section, but here in part 1, basically you're just adding dissimilar fractions. In other words, the old common denominator concept where you come up with the common denominator across the board by doing your calculations to the numerator and then coming away with a sum value. Now, once you get that sum value, don't worry about reducing in here. We're less concerned about reducing other than, when needed, and more about that later. What I'm more interested in than anything else right now is just being able to run through the computations to come away with a common denominator, add 3 values, and then give me a decimal equivalent on top of it with no significant digits past 5. All right, so we'll seldom, if ever, even in industry, go beyond 5 places past the decimal, but we just want to make sure that you understand the equivalency there. So that knocks out 2 concepts. One, equivalency between fractions and decimals, but also how to add dissimilar fractions. Part 2 is converting decimals that are given to you into percentages. Again, pretty straightforward, but the important takeaway here is that we're allowing for 4 significant values past the decimal point, meaning some of these decimals are, or rather percentages, are going to equate to something other than 4 places past the decimal. In other words, if you've got 4 places past the decimal point for a decimal value, what does that equate to in terms of a percentage? You're going back and forth between converting from percentages to decimals or decimal values to percentages. It would stand to reason that when you're giving a decimal answer, it's significant to know how many places past the decimal you want to account for in your answer. In the instructions here are given to you that it's 4, unlike the prior part 1 where it's 5. When you're thinking in terms of percentages, however, that's a whole value. So in turn, that will not equate to anything more than how many places. Because it's a whole value, you don't have to count places past the decimal. That's a percentage. And the percentages have to go from 0 to 100. So think about that in terms of a whole number. And then lastly, we have part 3 to this 3-parter, which is a separate doc, and it's called equivalency fractions, where you take and you're basically plugging in where you see voids for the numerator and the denominator. Just know that in 1 through 12, you have basically equivalency across the board, as in the top example in the front, in the very first row, before the header. In the end, wrapping things up, what you're going to do is you're going to represent shaded bars to represent 3 equivalent fractions from left to right. So it could be anything you want it to be. Just know that you're going to subdivide each rectangle to represent some fraction, and all 3 have to have the same value, much like what we've reinforced already. If you're able to comfortably go through this, you will be in great shape for what lies ahead, because anything beyond this is above and beyond what we're really emphasizing here in terms of the math scope. All right? Well, Any questions on that? If not, go ahead and get started, and good luck. Thank you very much for your attention.